start with aromaticity. So, conditions for compound, conditions for compound to be aromatic. Conditions for compound to be aromatic. So I think this you know. What are the conditions for compound to be aromatic? Compound should be cyclic. Number 2, it should be planar. Again, it should follow conjugation system. So it should be conjugated pi electron cloud. Conjugated pi electron cloud. Continuous delocalization. Continuous delocalization. And now, most times it should follow Huckel's 4n plus 2 pi electrons. Huckel's 4n plus 2 pi electron rule. What is n? What is n in Huckel pi electron rule? N is number of rings, number of double bonds, number of electrons in double bond, number of atoms,
starting from 0 to 1,
number of rings. Easy confusion. So simple. So n is nothing but any integer. Its value starting from 0, 1, 2, 3 and so on. So anything whole number or integer starting from 0. So that is it. So if compound is following all the rules, so compound will say to be aromatic. So complete set of rules it is following. So you can again write down same rules, all the rules. Means write down once again. Compound is cyclic. Compound is planar. Conjugated pi electron cloud. Continuous delocalization. So all 4 rules following, and except last one, that is if it is having 4n pi electrons. If it is having 4n pi electrons, then such system known as anti-aromatic. So it is cyclic, planar, conjugated, pi electron cloud, continuous delocalization. Continuous delocalization. Okay. So that should be. System is known as. Only thing is that here it is following 4n rule. Here another time it is following 4n plus 2 rule. So such system is called as anti-aromatic system. So what is non-aromatic system? What is non-aromatic system? Yes. So if it disobey any of these rules, 1 to 4, disobey any one rule, it may be acyclic, it may be non-planar, it may be there is no conjugation, there is no continuous delocalization. If it disobey any 1 to 4 rule, so that system is known as anti-aromatic, non-aromatic system. If system disobey any one rule from 1 to 4. Any one rule from 1 to 4. System known as non-aromatic. Known as non-aromatic. Okay. So very simple system, all of you know. Very good. So whether it is planar, planar, yes, cyclic, continuous conjugation, delocalization. So conjugation and delocalization is there. And what about pi electrons? Number of pi electrons? 6. So it is a 6 pi electrons. Any even number divisible by 4. Any even number divisible by 4. 4n system. Any even number divisible by 4, 4n system. Any even number not divisible by 4. Any even number, it should be even number. Even number not divisible by 4. It is a 4n plus 2 system. So this way simply you can test whether the system is 4n or 4n plus 2. Okay, so now this is a 4n plus 2 system. So it is a aromatic system. Good. जमते cyclic, planar, continuous conjugation and delocalization. आणि मग बघायचं 4n or 4n plus 2. So I will say number of pi electrons. So any system is non-cyclic, acyclic, all are cyclic system. Planar, all are planar system. Now continuous conjugation, delocalization. First मध्ये possible, not possible. Possible. Second, not possible. Third, possible. Okay. So all rules are following. So it is going to be aromatic or anti-aromatic. So what is that? Number of pi electrons? 2. So 2, and for plus charge 0. So total number of electrons 2. Divisible by 4? No. Not divisible by 4. So 2 pi electrons. So it is a 4n plus 2 system. 4n plus 2 pi electron system. So it is a aromatic system. Yeah. Here n is equal to 0. So it is not a number of rings or not a number of double bonds. Double bond is 1. Ring is 1. So it is 2 pi electrons. So n is any integer. When n is equal to 0, it is 2. So once any one rule is disobeyed. So since there is a sp3 hybridized carbon, so there is no continuous conjugation or delocalization. No need to check the number of electrons. What is the answer? It is a non-aromatic. Non-aromatic system. So So second one is non-aromatic system. What about third one? So everything is there. So total number of pi electrons. Now for minus charge, 2 electrons. Double bond, 2 electrons. So total 4 electrons. 4 electrons divisible by 4. So it is a 4n system. 4n system असेल तर that is a anti-aromatic system. Over. So cyclic, yes. Planar, yes. Conjugation delocalization, असेल ना. Conjugation you can write it different resonating structure. More is the number of resonating structure, more stable is the molecule. So everything is there. So just count the number of pi electrons. First, 2 pi electrons. Second, 6 pi electrons. Third, 4 pi electrons. 2 pi electrons. 4n or 4n plus 2. 4n plus 2 system. So it is a aromatic system. 6 pi electrons. Again 4n plus 2 system. So again it is a aromatic system.
How come, sir?
So there is no alternative.
Delocalization is not possible. When there are 2 minus charge, delocalization is not possible, I think.
6 pi alternate
6 pi is there. 6 pi is there.
6 pi is there. Can you write the resonating structures?
Can you get?
You cannot write. Can you write resonating structure for this one?
Yes.
So can you write resonating structures for this one?
Resonate is possible.
Then
Alternate conjugation is not there.
you think why it is not there? Can you write the resonating structure? That is the simple question.
Resonate structure is possible. Yes, possible.
So if you can write the resonating structure, okay. So now again, so conjugation is possible or not possible? What is the difficulty for conjugation? Negative charge means carbon in which hybridization state? sp, sp2, sp3. Carbon is carbanion. Carbanion. sp, sp2 hybridization state. One p orbital will be unhybridized. It will be filled p orbital. Okay. So that will be, and here pi electron cloud. So possibility is there. Conjugation होऊ शकते. Why conjugation is not there? Check. You just check to the reference books. Check whether it is an aromatic system or not. Check करून बघायचं. So I will leave it for you. Okay. So just check that one. I'm not giving you answer whether it is a aromatic or non-aromatic. You just check and just come to the conclusion. Fine. Next. What about this one? Anti-aromatic. Anti-aromatic in this one. So next question is that comment on bond length of carbon carbon bond in benzene and cyclobutadiene. In benzene and cyclobutadiene. So काय असू शकतं?
Some other bond length in benzene.
All bonds are equal in benzene due to aromatic nature. Aromatic nature due to resonance, delocalization of pi electrons. All carbon-carbon bonds are similar. So all carbon-carbon bonds of same length, same bond length. What about cyclobutadiene? So just guess it. Is it the same or different? Two types of bonds. Why? So now check. If a cysteine is aromatic, it is most stable. Anti-aromatic, what is the stability? Aromatic, then non-aromatic, then homoaromatic. What is homoaromatic? sp3 carbon atom. We'll come to that one later. So just non-aromatic, anti-aromatic. So aromatic will be most stable, then non-aromatic, then anti-aromatic. So anti-aromatic will be least stable. So then non-aromatic, then anti-aromatic. So it is having chance to come out of anti-aromatic nature. Okay, so it will try to get that one. So means if these double bonds are not in conjugation, okay, if they are not taking part in conjugation, they are stationary double bond. In that case, there is no delocalization of electrons. Since there is no delocalization of electrons, there is no anti-aromatic character. Okay, when delocalization is there, aromatic character is there. When no delocalization is there, no anti-aromatic character. So since to get non-aromatic character, these double bonds should be stationary. Therefore, this will be having 100% double bond character. This will be having 100% single bond character. So this bond length is lower than single bond. Okay, single bond length is higher than double bond length. Okay, in this case, since there is a all conjugation delocalization, you are having hybrid structure, resonance hybrid. So in this way, all carbon-carbon bonds are similar length. Okay, here not similar then due to non-aromatic character. If it is getting non-aromatic character, or if delocalization stops. So actually, practically it is not possible, but still practically it is observed that this bond length, double bond, is lower than single bond. Means there are two different bonds in cyclobutadiene. Okay, so that. Which of the following compound is acidic? One or two. Options are only one, only two, both 1 and 2, and none. Second one. Acidic means so acidic minus H plus. It can easily use minus H plus and the H plus are given here, so it will be having negative charge. So here also negative charge. So this is the aromatic, anti-aromatic. First one is anti-aromatic. This one is aromatic. 6 pi electrons. Conjugation devaporization. System is aromatic. So if it is getting aromatic nature, so it will be next. Comment to a dipole moment of the following compound, or which of the following compound is highly polar. Explain why. Yes. Third one is more polar. Towards what? Polarity towards what? Means where is the positive charge, where is the negative charge? If you are this double bond, if you are talking about this double bond, so here positive charge or negative charge? Positive charge. Here negative charge. Yes or no? Comment on animal values of compound 1, 2 and 3 or 6 aniline, 12 aniline and 14 aniline. Any guess? So what about benzene animal values? Hydrogen, H1 animal. H1 animal, what is the approximate values for aromatic hydrogen? 6 to 7. Yes, it is approximately 7.2 or 7.3. I will say 6 to 8 or 7 to 8 ppm delta values. Okay. So what about 12 anilines and 14 anilines? How to distinguish NMR compounds? How to distinguish aromatic compounds and anti-aromatic compounds based on NMR values? Hint तुम्हारा इधर. Okay. What is the hint? Why this is higher delta value? Why 7 to 8? Delocalization मुळे काय होते? So see, this is the benzene ring. Okay. So there is a pi electron cloud over this one. Okay. Hydrogen are there. Okay. So in NMR you are applying the magnetic field. So it is called as applied magnetic field. So if this is the direction of applied magnetic field, molecule will adjust itself such that, so this pi electron cloud will be like this. Okay. So direction of applied magnetic field, and due to this ring current, there is a generation of secondary magnetic field. Now that secondary magnetic field will be like this. So complete all over the ring, there is a secondary magnetic field. Okay. Now the direction of secondary magnetic field. So outside this ring, it is similar to your applied magnetic field. Okay. And inside, so it will be like this one. So coming inside and going outside. So this way secondary magnetic field direction. Okay. Now outside the ring, this is direction are same. Okay. And inside opposite direction. Okay. So this is called as paramagnetic zone. This is called as diamagnetic zone. If any hydrogen comes in paramagnetic zone, higher delta value. If reverse of the diamagnetic मध्ये जर असतील हायड्रोजन तर lower delta value. Now how to distinguish aromatic compound and non-aromatic compound? आता hint तुम्हाला बेंझिनची आहे. So in benzene, outer hydrogens are higher delta or lower delta? Higher delta. 7 to 8 means higher delta value. Means it is coming in paramagnetic zone. Fine. Means aromatic compounds, outer hydrogens are coming in paramagnetic. Opposite for anti-aromatic compounds. So if anti-aromatic compound is there, so this direction is opposite. Now this direction is like this one. Okay. So it is like this one. Now here it is going down. Means it is the up. So this outer hydrogens will be in diamagnetic zone, and here inner hydrogens will be paramagnetic zone. Means if inner hydrogens are there, they will go to higher delta value, and here outer hydrogens in anti-aromatic compounds, outer hydrogens will be lower delta value. आणि ही लोअर किती असते तर 0 पेक्षा पण कमी असू शकते. So it may be -1 or -2 also. Fine. And if it is aromatic, so this is the same compound. Now this is aromatic, anti-aromatic. So if anti-aromatic is there, so you are getting two types of H1NMR peak. For 3 hydrogen, 1 NMR peak, and other hydrogens 1 NMR peak. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So 9 hydrogen 1 peak, 3 hydrogen 1 peak. Predict the delta values, approximate delta values. Now this is the anti-aromatic or aromatic? Anti-aromatic compound. So anti-aromatic compounds, outer hydrogens will be opposite to this one. So it will be less. So less than 0 and approximately -1. Okay, let's say 0 to -1. So take it -1, approximately -1. And inner hydrogens will come approximately 6 to 7. Fine. 14 elements. How many types of protons? How many signals in H1NMR? And what will be the approximate delta values? So outer hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 hydrogen, 1 peak, 4 hydrogen, another peak. And the hydrogen is a peak. So very delta values, approximate delta value. So it is a first tell me aromatic or anti-aromatic? Compound is 1, 2, 3, 4, 5, 6, 7, 7, 8, 14, 14 electrons, 14 pi electrons, 4n or 4n plus 2. Divisible by 4 or not divisible by 4? Not divisible म्हणजे system 4n plus 2. Aromatic system. Aromatic system म्हणजे outer hydrogens. Aromatic directly लक्षात ठेवा. बेंझिन तुम्हाला माहिती आहे. बेंझिनला रेफरन्स ठेवायचा आपला कधी. सो ही व्हॅल्यू लक्षात ठेवा. ही माहिती आहे आपल्याला सर्वांना. 7 to 8. Okay, for aromatic system, outer hydrogens higher or lower? Higher. So 10 hydrogens will be 6 to 7, and inner hydrogens will be approximately 0. किंवा -1 0 2 -1 got it. Okay, so perfect googly asked me next December 15 question for 2 marks. पहिली गोष्ट तर sorry maybe December 15. So June 15 for 2 marks. So write down question. The compound that gives precipitate on warming with aqueous AgNO3. Warming with aqueous AgNO3 is मला फार आवडला प्रश्न. मला आवडला म्हणजे वाटतंय सोडवा. The compound that gives precipitate on warming with aqueous AgNO3. One more question we can discuss which you asked. कोणाजवळ तो व्हॉट्सअपचा क्वेश्चन आहे का? मागे एकदा विचारला लॉंग आहे. What is the answer? What is the answer?
Second one.
वाटतंय नाही. What is the answer?
Third one.
Second one? Oh, sorry. Reason. Yes. Now confusion is between only 2 and 3. Second and third. Third one. Why third one?
Easily after losing Br minus it will get stabilized.
हाँ, ये tricky होता है. Anything is treated with AgNO3. So silver, एक लक्षात आहे. Silver is having strong affinity towards bromine or halogens. And outgoing species काय असेल? AgBr. Means Br is going as a Ag plus and Br minus. So Br minus it is going. So whatever left is a cation. Okay. So here positive charge, no problem. So it is not possible. So it will be least stable. So convenient between only 2 and 3. So after losing Br minus, it should be positive charge, and here it should be positive charge.
6 electrons.
So this system and this system. So this system is anti-aromatic. This system is aromatic. Got it? Okay. So our question paper, go directly to 33, 34, 35. 33, 34, 35. Pentylene, azulene, heptylene. So do you have that question last sometime back I asked or some set question, some question posted in WhatsApp, no? So this will be a simple question. So this is a set question paper. A means anti-aromatic, Na means non-aromatic, A means aromatic. A means aromatic, A means anti-aromatic, Na means non-aromatic. काय झालं? ते मागचं बटन दाब सर. दाब सर. हां. So 1, 2, 3, 4. So what about third? Third one is non-aromatic. Third one is non-aromatic. Third one is non-aromatic. Third one हा चुकलाय. Third one is non-aromatic. Third one. Third one म्हणजे हा पण चुकलाय. So either A or C. 1 and 2 A aromatic, or 1 and 4. One is third one.
Option is wrong.
1
and 2. Option C 1 and 2.
So 1 and 2 are aromatic. 1 is aromatic, 2 is aromatic. Third is non-aromatic, fourth one is anti-aromatic. Simple. So so 13, 14, 33, 34, 35. Heptadene, pentadene, azulene, heptadene.
Sir, I question on the 13 number.
See. So next from December 14. December 14 question. NET examination 2 marks. The compound that is not anti-aromatic is the compound that is anti-aromatic is